Let's have a look at the answer to question 1b, part 2. So we have been asked, what would the value of lambda, our rate, need to be so that under a Poisson model at least 95% ate at least one serving? Okay, so what I've given there, here's our distribution. We know we've got a Poisson with a rate of 3.2, so that's what we've had. And what they're saying now is we are going to figure out what this new rate will be so that, and this is when I've got to look at what we've been information there, the probability of getting at least one serving of vegetables that probability has to be at least 95%. Okay, so that's what I have been given. Now, because I'm trying to find a rate, one of the things that I'm aware of is that I need to use my formula to solve this. And when I use my formula, and I'm just going to go and grab that from my other screen. Let's put that in here. So there is my formula. And what we know about that formula is that we need to simplify this formula in order to be able to solve and use it. So the way that we do that is we want to use an x value of 0. And if I substitute in an x value of 0 in there, then what happens when I have lambda to the power of 0, anything to the power of 0 is 1. So that will simplify just simply to the number 1. 0 factorial is also going to simplify to the number 1. So by having a probability of equal to 0, I can simplify this formula on the right hand side. And so I'm going to take this information that we've got here about being greater than or equal to 1 and say, okay, well, if I think about greater than or equal to 1, so if I think about my number line, 0, 1, 2, 3, 4, etc. If I want greater than or equal to 1, that would be everything on that side there. If that probability is at least 95%, that means this little piece on the end, the 0 probability, needs to be less than 5%. So what I'm going to change that to is the probability x equals 0, not equals, it needs to be less than 5%. Okay, so I'm taking the information and rearranging it, or manipulating it, in order to be able to use a much more simplified formula and solve. Okay, so that's what I want to do now. So I'm going to take this lovely formula here, probability x equals 0, and I'm going to say, right, remember this formula here, now that we've put 0 into that, becomes 1 times e to the minus lambda over 1. The 1's are going to simplify, so this whole formula just becomes probability x equals 0 equals e to the power of minus lambda. Okay, now what I can do is I know the probability needs to be less than 5%. So let's put that in here. I'm going to just say, well, what if that is exactly 5%? And I want to be able to solve that formula. So I'm going to change my 5% into a decimal. So 0.05 equals e to the power of minus lambda. I'm just going to come over to the side here. And now I know the opposite of e, the inverse of e, is my ln, or natural log. So I'm going to apply ln if my pen keeps behaving. No, it doesn't want to behave. Okay, let's try that again. Let's do ln of 0.05. And when I have ln of e to the power of minus lambda, this ln and e, these are inverses, they will cancel out. So that means I'll have ln of 0.05 equals minus lambda. So then I can get rid of this negative sign take that to the other side, or multiply both sides by -1 essentially. And what I'm going to get is negative ln of 0.05 is equal to lambda. And now I'm going to just put that into my calculator. And I'm going to just grab a standard calculator here and go the negative log of 0.05 equals 2.9957. And I'm going to round that to, let's go to 2 decimal places, so that's going to become 3.00 to 2 dp. So that is what our rate would need to become in order for the probability of 0 to be less than 5%, which is equivalent of the probability of being at least 1 being more than 95%.